Hello friends, I am Gourav Gupta and I welcome all of you to BYJU'S exam prep, formerly called as Grade Up. Now BYJU'S exam prep is the most comprehensive app for all examinations including CAT and other MBA entrance examinations. Now here we provide our aspirants with end-to-end preparation so that they can achieve their desired goals. Now today I welcome all of you with our next session in the series, which is based on ratio and proportions. Now, as you all know that in these sessions, we are going to basically discuss the basics of all these topics that will come on your way in the QA section, in the quantitative aptitude section, in CAT or any other entrance examinations. Also, these sessions will be helpful in case you are preparing for any other entrance examinations such as bank PO or any other SSC examination. If you are preparing for UPSC examinations, all these things will be helpful for all of you. All right. Now, in my previous sessions, like if I talk about the previous series of sessions, then we have gone through each and everything that is related to percentages. So you can scroll and you can find all these sessions which will prove to be helpful for all of you. So friends, let's start with the first session, ratios and proportions in the series of ratios. All right. Now, first of all, let us understand what a ratio is and what a fraction is in comparison to a ratio. All right. So I'll take a very small example. Now, these words you will encounter in a lot of questions. So some of the questions will give you the ratio of any two of the mixtures. Some of the questions will talk about the fraction of these things. Okay. So let's talk about what first of all a ratio is. So let's say a vessel you are given contains 15 liters of wine and 55 liters of water. All right, so it has 15 liters of wine and 55 liters of water. So if I have to calculate the ratio of wine and water, all right, the ratio of wine and water, I'll write it like this. And this ratio will be 15 is to 55. So quantity of wine is 15 and quantity of water is 55. All right. Now, what operations we can perform on ratios? So I have the ratio of two values. The values are 15 and 55. So what we can do is we can take out some common factors to express a ratio in the simplest form. Okay. Now, even if you leave this ratio like this, it will not make any difference. It will be perfectly fine. But it is always advisable to convert a ratio in its simplest form. Now let us understand what do I mean by simplest form. Okay. Now by simplest form, first of all, I mean that we'll take out all the common factors among these numbers. So 15 and 55, if I take out common factors, which is 5, okay. So if I take out the common factor of 5, I'll be left with 3 here and I'll be left with 11. So I can say that this is the simplest form of the original ratio. Again, I'm telling you, there is no harm even if you'll leave this ratio like this. All right, fine. Okay. Mr. Narula, Payal, Raj, good evening. Hello, Mr. Narula. Okay. So friends, let's continue this. So wine and water, they were in the ratio 15 is to 55 and I've expressed this ratio in the simplest form. So the first thing, while expressing in the simplest form, what we do is we'll take out the common factors. All right, this is one thing. The second thing, which will be helpful for all of you to convert any two, like the ratio between any two numbers in the simplest form, is try to express the ratio in terms of integers. All right. So let's say away from this, if I say that the quantity of wine is 15.5 liters and the quantity of water is 55.5 liters. So I can say that the ratio of wine and water will be 15.5 is to 55.5. All right. Now I can see the numbers in decimals on both the side of this ratio. Okay. So what I'll do is I'll first of all try to convert both these decimal numbers into the integers. Okay. So in the first case, what I have done is I have taken out a common factor of 5 What you may also do in a ratio, you may multiply both the numbers by a same number. Okay, so I'll multiply both the numbers by 10. So I'll get the value 155 is to 555. Okay, now you may take out 5 common from both of them to express again in the simplest form. So the first value will become 31 and the second value will become 111. All right, so 31 is to 111 will be the simplest ratio when wine and water were present in these quantities. All right, so these are two important things that we can perform on ratios. I'll repeat this. First of all, if you are given a ratio among two numbers or three numbers, you can take out any common factor and write it in the simplified form. Okay, that means you can divide all the terms expressed in a ratio by a same term. Okay, also you can multiply these values with the same number. All right, so you can take out a common factor or you can multiply all these terms with a common number. It will not change the ratio. Okay, so this is one thing talking about ratios. Okay, now let's talk about this term fraction. All right, so quantity of wine here was 15 liters and quantity of water was 55 liters. All right, so the ratio in which wine and water are present is equal to, so I'll write the simplified ratio now, 3 is to 11. All right, now if the question is referring to the fraction of wine or the fraction of water, so first of all, fraction of wine. So fraction of wine that will be present in this case. So how to write fraction of wine? So it will be the part of wine. Okay, so wine divided by the total quantity. All right, you can use these values from the ratio as well. So portion of wine is 3 and the total will be wine plus water, that is 3 plus 11. So I can say that fraction of wine that will be present in this vessel will be 3 by 14. Okay, so I can say that 3 by 14th of the vessel will be wine in this case. All right, similarly, if I want to find fraction of water, okay, fraction of water will be part of water, that is 11, again divided by total quantity, which is 14. So 11 upon 14 will be the fraction of water that will be present in this vessel. Okay, so be careful with these terms. Don't consider that the fraction is the ratio of wine and water. No, these are two different things. Ratio of wine and water, fraction of wine, fraction of water, they are absolutely different. All right, so these are something basics. Now let's move on to and have a look at some of the properties which are related to ratios, which will help you directly in questions. Okay, so first of all, if you are given that a upon 9 equals b upon 7, which is equal to c upon 4. Okay, so this type of information is given to us in the question. Now using this, we require the ratio of A, B and C. So how will we get it? I'll give you 5 seconds. You may write the ratio of A, B and C. If A upon 9 is equal to B upon 7 is equal to C upon 4. Meanwhile, Krupa, good evening. Shreya, good evening. All right. So anyone can respond to this one? Okay, so A upon 9 equals B upon 7 equals C upon 4. All right. Now, since all these are given equal, I'll assume that all of them are equal to K. Okay, all of them are equal to a constant K. So A upon 9 was already equal to B upon 7 and C upon 4. And I've assumed all three of them to be equal to K. All right. Okay. Now, if I write the value of A, B and C in terms of K, what will be these values? These values will be A is 9K, B is 7K and C will be 4K. All right. So now I have written all three of them in the form of K, 9K, 7K and 4K. So if I want to find the ratio of these three, the ratio will be 9K is to 7K is to 4K, and I'll take out common factor among all three of them. as we can see that K is the common factor. So the ratio of A, B and C will become 9:7:4. All right. So this is one thing that will help you in a lot of questions. All right. So this was property number 1. Okay. Now let's move on to the next thing. If you are given that A is to B is to C is 1 upon 9 is to 1 upon 7 is to 1 upon 4. So this is given to us. Okay. Then we have to find the simplified ratio of A, B and C. Already the ratio is given, but as you can see that the ratio is given in the form of fractions. Okay. 1 upon 9 is to 1 upon 7 and 1 upon 4. Now it is understood that obviously it gets very difficult for us to basically solve the questions when things are given in fractions. We always like things in integers, okay, the simplified form. All right, so already the ratio is given, but I'll calculate the simplified form of this ratio. Okay, so I'll give you an example for that. So consider that A is to B is equal to, so meanwhile those who can find the answer, please do that and post it in the comment section. Okay, so A is to B, let us say that it is given as 1 upon 2 is to 1 upon 3. Now at the beginning of the session I told you that we can multiply both the values in a given ratio by a common number. Okay, now I have fractions 1 upon 2 and 1 upon 3. So by what common number these two fractions should be multiplied so that they will give me an integer. Okay, now in the denominator I have 2 and 3. So that number should be a multiple of 2 and 3. Okay, so a multiple of 2 and 3, the smallest one is 6. So I'll multiply both the sides of this ratio by 6. Okay, so 6 into 1 upon 2 will give me 3 and 6 into 1 upon 3 will give me 2. So the simplified form of this ratio will be 3:2. All right. Okay, so this is one thing. Now let's move back to the original question. Now here I have the ratio 1 upon 9 is to 1 upon 7 is to 1 upon 4. All right. Now what I'll do is I'll multiply all these three fractions with a common number, which is a multiple of 9 as well as 7 as well as 4. So there is no need to calculate that multiple. Just multiply all three of them by 9 into 7 into 4. Okay, so we spent 5 seconds in calculating the least common multiple LCM of 9, 7 and 4. No need to do that. Just multiply all these three ratios with the product of 9, 7 and 4. Okay, and there is also no need to multiply these three numbers. Now when 9 into 7 into 4 is multiplied by 9, 9 will get cancelled and I'll be left with 7 into 4, that is 28. All right, then when this product is multiplied by 1 upon 7, 7 will get cancelled. I'll be left with 9 into 4, that is 36. And finally 4 will get cancelled and I'll be left with 7 into 9, that is 63. Okay, so 28 is to 36 is to 63. 28 is to 36 is to 63. All right, will be the simplest form. So Kamlaj, you have like given partially correct answer 28 36 tak theek tha. Okay, but last term was different. VM, you have given a perfectly correct answer. Krupa, you have done the same mistake as Kamlaj has done. Okay, so let's continue. So be careful with these simple multiplications or divisions. All right, so 28 is to 36 is to 63 will be the simplest form of this ratio. All right, now why I'm telling you all these things, because these things are very small. Like these things can be one of the small part of a big question where you need to simplify these ratios in the given manner. Okay, let's move ahead and look at the next simplification. Okay, all right, now the third case, I'm given 7a equals 5b equals 4c. Okay, this is similar to the first property that we have seen, I believe. Okay, so 7a equals 5b equals 4c, and I'm asked to calculate the ratio of a, b and c. So first step, I'll definitely assume 7a, 5b and 4c, which are already equal to another constant k. Okay, and then I'll write the value of A, B and C in terms of K. So it will be K upon 7, B will be K upon 5 and C will be K upon 4. Alright, so from here I can say that A is to B is to C can be written as 1 upon 7 is to 1 upon 5 is to 1 upon 4. Alright, now looking at the previous question that we have just done, previous property, here the ratio is expressed in terms of fractions. Now in order to obtain the simplified form of this ratio, what I'll do is I'll multiply all these three fractions with the product of 7, 5 and 4. Alright, just multiply them with the product of 7, 5 and 4. So the value obtained will be 20 is to 28 is to 35. Okay, so this is the simplest ratio of A, B and C. Alright, fine. Now I can do the same question using one more method. Okay, that might be a little shorter. Okay, now I was given that 7A equals 5B equals 4C. Now instead of assuming them to be equal to K, you may assume them to be equal to the product of 7, 5 and 4. Alright, K was a constant, so it can be any number. So I'm assuming that this constant K is the product of 7, 5 and 4. Alright, so here the value of A will be 20, value of B will be 28 and the value of C will be 35, which will decide the ratio of A, B and C. Okay, so it will take comparatively lesser time as the previous method. Both the methods are good. Okay, so it's totally up to you, whichever method you want to use, it's absolutely fine. Okay, now let's go ahead and look at the next thing, which is used most frequently. Okay, I am given the ratio of A and B and the ratio of B and C. Okay, so the ratio of A and B is 3 is to 5 and the ratio of B and C is 4 is to 9. Now combining them, I have to calculate the ratio of A, B and C. Alright, so let's see how many of you can write a correct answer. So go ahead. So wonderful, Raj, VM, Krupa, all of you are replying to the answers to the questions that I'm asking. So A is to B and B is to C are given. I am looking for the value of A is to B is to C. Okay, now let's see what to be done. Now I'll find out common link between these two ratios. The common link between these two ratios is B. Okay, but the number, the value corresponding to B is not common in these two ratios. Okay, so what I'll do is, since I'm given the ratio of A is to B as 3 is to 5 and ratio of B and C as 4 is to 9. So what I'll do is I'll make the common value for this common link. Okay, so B is the common link between them. So I'll try to make this part and this part equal. Okay, how can I make them equal? I'll multiply first ratio by 4. The ratio will become 12 is to 20 and I'll multiply the second ratio by 5. Alright, the ratio will become 20 is to 45. Okay, now I can safely combine these two ratios because the values corresponding to B are now equal. Okay, so I can write A is to B is to C as 12 is to 20 is to 45. Okay, so this is the ratio of A, B and C. And yes, Krupa, you have given Raj, Krupa, VM, wonderful. So all three of you are responding. All three of you are there present in the session. So A, B and C ka ratio kitna ho jayega? It will be 12 is to 20 is to 45. All right. Okay. Now let's move ahead and look at the next thing. Okay. So this was basics of ratios. Okay. Now let's talk about the next important thing in this chapter, which is variations. Now friends, concept of variations can be used at a lot of places. Obviously, there is a direct application in the questions. So you will find direct questions from variations. Okay. Also, the concept of variations is used in the chapter of time and work. This is one place. Also, it is used in the chapter of time, speed, distance as a shortcut. Okay, so when we'll look at time and work and time speed distance, I'll definitely like take a reference of variations. Okay, so if you are clear with the concepts of variations, then you can save plenty of time in solving the questions in time and work and time speed distance, which are one of the which are among the most important chapters in this section of QA. Okay, so you can see that at least 4 to 5 questions definitely appear in CAT from these two chapters combined. Okay, so let's look at variations. So first of all, if I'm given a statement that A varies directly as B. Now, what do I mean by this statement? A varies directly as B. Okay, now this statement mean to say that if B will change, listen to each and every word that I'm using. Okay, A varies directly as B means that if B will change in a certain ratio, then A will also change by the same ratio. Okay, I'll repeat. If B will change in a certain ratio, A will also change by the same ratio. All right. So that means if B is multiplied by 2, then A will also be multiplied by 2. If B gets halved, A will also become half. If B is multiplied by a fraction of 2 by 5, the same effect will be there on A. That means A will also be multiplied by 2 by 5. All right. Okay. So the same change will happen in terms of ratios. All right. So multiplication will be followed. So by whatever constant B will be multiplied, A will also get multiplied by the same constant. Okay. Now, if we understand this thing, so we can always say that the ratio of A and B, the ratio of A and B will always remain constant. All right. So A upon B will always remain constant because whatever term will be multiplied in the denominator, the same term will be multiplied by A in the numerator. And this common term which is multiplied in both numerator and denominator will get cancelled. Okay. So I can say that A upon B will always remain constant if I'm given that A varies directly as B. All right. One thing. Next thing, if A varies inversely as B. Okay, so in the similar manner, I can say that if B changes in a certain ratio, okay, if B changes in the certain ratio, A will change by the reciprocal of that ratio. All right, I'll repeat. If B changes in a certain ratio, then A will change by the reciprocal of that ratio. All right. So that means if B is multiplied by 2, if B is multiplied by 2, then A will be multiplied by 1 upon 2. All right. If B is multiplied by 2, then A will be multiplied by 1 upon 2. If B is multiplied by 1 upon 3, that means if B becomes 1/3, then A will be multiplied by 3. That means A will be tripled. All right. Fine. If B is multiplied by 5 upon 4, then A will be multiplied by 4 upon 5. Okay, fine. Now, if I look at this particular thing, I can say that like in previous case, we saw that A upon B will always be a constant. Okay, in this case, the product of A and B will always be a constant. All right, the product of A and B will always be a constant. All right, okay, or I can say that in this first case, A will be equal to K times B. In the second case, I can say that A will be equal to K upon B, where K is a constant in both cases. Okay, am I clear? So this is about variations. Yes, Karamjot, it is basically directly proportional and inversely proportional. Okay, so you can call it by different names. So I've said that A varies directly as B. You can also say that A is directly proportional to B. Okay, in the second case, you can say that A is inversely proportional to B. All right. Okay. Now let's have a look at one very wonderful question that comes that normally comes from this chapter. Okay. So just have a look at this question. Just read it quickly. So I've just selected this question, okay, because a lot of us will not commit any mistake in the basic questions of variations. Also, you'll not find any basic question in the examination. Now, this is one question, this is one place where we tend to commit mistake. All right. Now, this question, like it appeared in CAT, I've changed the language a little bit. Okay. This question appeared in CAT, okay, and there were two parts to it. So this is part number one, and I'll take you to the second part on the next slide. All right. So let's read this question. The question says that the reduction in speed of a train, important word, reduction in speed. Okay. So reduction in speed of a train is directly proportional to the square root of the number of wagons attached. Wagons is like the bogies. All right. Okay. So reduction in speed, obviously the speed of train will reduce when we'll keep on attaching more and more wagons. So this is what they have said. The reduction in speed is directly proportional to the square root of the number of wagons attached. All right. So the statement says that reduction in speed, I'm taking it as R. Okay. It is directly proportional to the square root of number of wagons which are attached. All right. So removing this sign of proportionality, I can say that reduction in speed will be equal to K times under root N. All right. This is given to us. Okay. I'll explain it again. The first statement was the reduction in speed, which I have taken as R, is directly proportional to the square root of number of wagons attached. So N is the number of wagons. So I can say that R will be equal to K times under root of N, where K is the constant. All right. Okay. Now next statement is saying that when no wagon is attached, the engine runs at 60 km per hour. Okay. So in absence of any wagon, the speed is 60 km per hour. Now, as soon as I attach 16 wagons, the speed is reduced to 44. Okay. The speed is reduced to 44. All right. So that means when 16 wagons are there, now the train is running at a speed of 44 km per hour. Okay, so what is the reduction in speed from 60 to 44? Okay, the reduction in speed here is 16. So I'll substitute this value. 16 is the reduction in speed. Be careful. This is not speed. This is the reduction in speed. All right. So speed is reduced by 16, which will be equal to K times the square root of number of wagons. So number of wagons attached is 6. So I can say that the value of K will be equal to 4. All right, keep it aside. Am I clear up till this point? So the value of K is 4. Okay. Now as a question they are asking, what will be the speed when 36 wagons are attached? All right. So I'll start the case from the beginning only. Okay. So when no wagon was attached, the speed was 60. Now, when 36 wagons are attached, the reduction in speed will be equal to K times under root of the number of wagons. Now, we have already calculated the value of K. The value of K was 4. And now in the second case, the number of wagons is 36. So I'll substitute it here. And the reduction in speed comes out to be 4 into 6. That is 24. Okay. Now in this case, the speed will be reduced by 24 km per hour. So original speed was 60. When it will be reduced by 24, the speed will become 36 km per hour. All right. Am I clear? So the question was, what will be the speed when 36 wagons are attached? The speed will be 36 km per hour. Okay. Now let's talk about one more case. Let's say instead of 36 wagons, we are attaching 49 wagons. So what will be the speed when 49 wagons are attached? All right, let's calculate this one. So reduction in speed is equal to K times under root of number of wagons. Okay, now the value of K is 4. Under root of 49 is 7. So reduction in speed will be 28. All right, so the speed will be 60 minus 28, that is 32. kilometer per hour. So I believe now you must have understood when I've taken the next example. Wonderful VM. Your answer is absolutely correct. Okay. Now Karamjot, yes, 28 kilometer per hour was the reduction in speed, and the speed will become 60 minus 28, that is 32. Okay. Now you will definitely find 28 among the options. So they'll definitely give 28, but the answer is not 28. Answer is 60 minus 28, that is 32. 28 was the reduction in speed. 60 minus 28 will be the speed at which the train will be running. Okay. Now this was the first part of this question. Little easy. Okay. Now let's move on to the next part of this question. Okay. Now the initial information is absolutely same, which says reduction in speed is directly proportional to the square root of the number of wagons attached. When no wagons are attached, the engine runs at 60. When 16 wagons are attached, the speed is reduced to 44. Okay. So with this information, what we had done earlier was we got the value of k. So the equation was, or the relation was, reduction in speed was k times under root of number of wagons. Okay. So we were already given this portion. All right. So I'll write the value of k, and this relation reduction is k times under root of number of wagons. All right. Now let's read this next question. The question is, what can be the maximum number of wagons? Charan, you're telling me that you are having difficulty in removal and replacement. So Charan, I'll be discussing this particular thing, mixtures, allegations, and averages in the next few sessions. So please keep following this session. Okay. All right. So reduction in speed is equal to k times under root n, and the value of k is 4. The question is, what can be the maximum number of wagons that can be attached to the engine so that the train can just move? Okay. So the train, obviously, it will keep on attaching wagons. It will keep on reducing the speed, and there'll be a moment when the train will not move. But this is what we don't want. We want the maximum wagons that can be attached so that the train is just moving. Okay, fine. Now, when no wagon was attached, the speed was 60. Okay, when no wagons were attached, the speed was 60 km per hour. When the number of wagons, when the number of wagons was 0. All right. Now, what I'll do is, I will calculate VM. This is the trick here. So wonderful VM. Okay, so let's see what will be the actual answer. Now, speed is 60 when no wagon is attached. So what I'll do is I'll try to find out the number of wagons after which the train will come to the rest. The train will not move. Okay. So if the speed is 60, I can say that if the speed is reduced by 60 kilometer per hour, then the train will not be running. So the speed of train will be 0 kilometer per hour. So what I'll do is I'll substitute reduction in speed as 60. All right. So reduction in speed as 60, and we'll calculate the number of wagons. Okay. So if I'll substitute 60 here, so 60 is equal to, the value of k was 4, under root the number of wagons. So under root n is equal to 15, and the value of n is 225. Okay, 3 of you have given. So as soon as I'll see 225 among the options, I'll mark the answer, and my answer is incorrect. Okay. Now the question is not asking what will be the number of wagons so that the train comes to rest. Okay. Now, after attaching 225 wagons, the speed of the train will be 0 km per hour. Okay. Now, since I want the train to just move, any number of wagons which is less than 225, any number of wagons which is less than 225, the correct answer will be at 225, the train will come to rest, and if you'll subtract one wagon, if you'll remove one wagon, that means if the number of wagons is 224, then the train will be just moving. Okay, obviously you cannot remove half a vegan or you cannot attach half a vegan. So that is why I have subtracted entire one vegan from 225 vegans. Okay, so 225 minus 1, that is 224, will be the correct answer to this question. And among the options that they will give, let's say 225, 15, 20, and none of the above. All right, so we'll not see this option 224, but the answer is 224, which is none of the above, and none of the above is the correct answer. Okay, so this is how, like, the person who will set the CAT examination play with our psychology. Okay, so we have to be alert at each and every time. We have to be keeping all these things in our mind at every time. Ratios and proportions. Tomorrow at the same time, I'll be coming up with the questions of averages. All right, so with the concepts and the questions of averages. Now averages is a very important chapter, easy, but definitely I'll be coming up with basic concepts as well as some applications of those concepts in some higher level questions. All right, okay, so that's all from my side, friends. Now this is the schedule of all the sessions that we run, like for the entire week here at the channel of BYJU'S exam prep. So all these sessions are free. Okay, so you may plan your day accordingly and you may attend any of these sessions. All right, now friends, if you channel, all right, these are the different CAT courses and courses for other MBA examinations that we offer at BYJU'S. Okay, so BYJU'S exam prep, you will find all these courses for CAT 22, for CAT 21, for like a comprehensive course for CAT 21 as well, to score 99 plus percentile. If you are not targeting CAT but you are targeting any other entrance examination, so for SNAP and MAT, okay, the details of that batch is on this screen. All right, so this is a comprehensive course for the preparation of specifically SNAP, Narsi Munji, CMAT, and TISNET. Okay, so you may just have a look at these details, and for other details you may call at this number which is given at the bottom of the screen. All right, this is the list of experts that we have on our panel. Now if you'll see, we have on an average on an average our experience is more than 15 years. Okay, so I myself has a total experience of more than 14 years, teaching in a lot of institutes like Time Education, Career Launcher, IMS. So I've taught at all these institutes. Now I'm teaching for all of you at BYJU'S exam prep. Now this is about the two courses that we offer for CAT 21, a percentile booster course on the left hand side, and a complete course for all the aspirants who are preparing for CAT 2022, the next year. Okay, so complete details are mentioned on the screen, and again for any other detail. Right, so friends, that's all from my side for the day. We'll see you tomorrow with, you can follow us on Instagram, Facebook, and join us on Telegram. You can subscribe us as well, like our YouTube channel. That's all. Thank you very much, friends. Have a nice day.